Oh my goodness. Scalloped potatoes and beans. Hmm, what could I make? Ooh, desserts. What kind of desserts do we have here? I could make, what in the world? What does that even mean? Gelato. Ooh, bread pudding. I can make caramel apple crepes. Or I could just order out. Oh, hi everybody. Didn't know you were. Yeah, just hit the intro. So nah. Hey guys. So last time we talked about volume of three-dimensional objects, specifically prisms and pyramids. Well, today we thought it would be good to talk about surface area of those same types of objects. So let's start with definition. Just kidding. So we have the surface area. So what is the surface area anyways? So the surface area is, make believe this is a little box, okay? The surface area is how much material would I need to create this box, assuming it was hollow. Okay, obviously this is an eraser that I've poked holes in because I like to poke holes in erasers. But if you make believe that's a little cardboard box, the question for surface area would be, how much cardboard would I need to create this box? And as you can see, this is a rectangular prism, and we're going to talk about that today. So, with prisms, what you want to do is you want to find the area of each face and find their sum. So you want to add up all the areas of the faces, okay? And for pyramids, you do the same thing. Find the area of each face, add them up, and remember, use the slant height. And we're going to go into that in just a second. So you may find surface area to actually be a bit easier than volume or a bit harder depending on your taste. Volume is just one formula, quick and easy. Surface area, you have to actually think about it a bit more. So let's start with a rectangular prism. So as you can see, we have a rectangular prism with a height of 2 inches, a width of 3 inches, and a length of 5 inches. Okay. If you want me to be honest, I could call this the length and that the height, and it just depends on how you lay the box. Goodness, you know, sitting in school that always confused me. Which one's the width? Which one's the height? Which one's the length? Sitting here as a teacher, that still confuses me. Which one's the width? Which one's the length? Which one's the height? With something like this, it does not matter. Okay. What matters is when we're finding the surface area is that we find the surface area of each of the faces. With a rectangular prism, all I see are 3 faces, but I know that there is a face opposite of each of these 3 visible sides. To this top, there's a bottom with the same area. To this front side, there's a back side with the same area. And to this side, there's another side, same area. So what we have here, what we want to do then is we want to find the area of each of the faces. Because it's a rectangular prism, I know that this area will be doubled because this and the side opposite it have the same area. So what I'm going to do is I'm going to find the area of each of these 3 faces and multiply them each by 2. So we've got 2 times 2 times 3. That represents the 2 sides that have this area. The one here and the one back here that you can't see. Okay? Then I've got 2 times 3 times 5. That represents the top, because it's 3 by 5, and the bottom that you can't see. And there's, you know, the top and the bottom, so that's 2. And then we've got 2 times 2 times 5, and that represents this front side with a length of 5 and a height of 2, and the back side that you can't see. Okay? So when you do all the math and add that all up, we get 12 plus 30 plus 20, which is 62 inches squared. Yes, we were talking about square units because we were talking about area. So that's a rectangular prism. Okay? Moving on. Let's look at a triangular prism. Okay? So these are a bit different. Yes, you could have an equilateral triangular prism, in which case all 3 of these rectangles would be the same area, but that's too easy of an example. So I wanted to show you an example where that's not the case. We've got an isosceles triangular prism. So the triangle in the front and in the back are going to be the same area. And remember, to find the area of a triangle, it's 1/2 base times height. So we're going to have 2 times 1/2 times the base of 4 times the height of 2. Okay, and there's 2 of those. But then when I look at the rectangles, even though they may look the same, these 3 rectangles are not the same. How do I know that? Because the lengths of my triangle here. I know my bottom rectangle is going to be 4 times 10. That's the bottom. But the sides are going to be 3 times 10 because these legs of the triangle here are 3 feet. So we're going to do 3 times 10 and 3 times 10. So when we show the math here, we've got 2 times 1/2 times 4 times 2. That's for both the triangles. Then we have 10 times 4. That's for the bottom rectangle. Then we have 2 times 3 times 10. That's for both of the side rectangles. But if you flip the triangular prism on its side, then they would be the bottom rectangles. It's all the same. So just pay attention to what you're doing. And then when you multiply that, you have 8 plus 40 plus 60, which is 108 feet squared. Okay, that's how much, if you imagine this being a tent, that's how much material you would need to create this tent. Okay. Oh, it's on the back of this. And then we have a pyramid, and I have must have rubbed this on something because some of my writing smeared. But we have a pyramid, okay? This is a square pyramid. So we want to find the area of each of the bases. As you can see, I've got a side length of 2, and because it's a square pyramid, I know all the side lengths are 2. So the area of that base is just 2 times 2. It's a square. But then we've got 4 equal triangles, not equilateral triangles, but equal in area triangles. How do I know that? Because all 4 of their bases are 2, and they reach the same point. So here's where it gets a bit confusing for people. You have a height here, and you know the area of a triangle is 1/2 base times height. But these triangles are not sticking straight up. They're slanted. So this height, I even wrote up here, ignore this height. This is only used for volume. The height you want to use is the height on the triangle itself. It's called the slant height. So this is the slant height. This is what's used for surface area. Why? Because your triangle is, you guessed it, slanted. Okay? So you find the area of one of these triangles, we would have 1/2, right, times the base of 2 times the slant height of 4. But I've got 4 triangles, so that's why I've got 4 times 1/2 times 2 times 4 plus 2 times 2 because there's only one square at the bottom. That would give us 16 plus 4, which is 20 feet squared. Okay. If you have any questions, you can leave it in the comment section. Feel free to like, subscribe, share this video if you need to, whatever. But watch it as many times as you want, you guys. Just let me know if there's anything I can do to help you further here. Is there a topic you need me to cover? Just let me know. So that is surface area of prisms and pyramids. And I am going to go and see. Okay. I guess I probably should instead call Papa John's. Still math.